share some of the testing stuff that I do every single day. So every single day I tweak something on here, and then I go through the testing procedure and I see if I get any odd results. And I'd say about half the time I get something that I'm not expecting, whether it be odd noises from different resonances happening, or I'll get really weird RF spikes or weird EMP spikes on the oscilloscope there. Yeah, lots of interesting stuff. So just from the get-go, I will walk y'all through what this thing is and the general gist of how it's supposed to work. So I think it was 2016, Alexey Chekurkov, maybe it was 2018, Alexey Chekurkov, Russian garage inventor, came up with this idea based off of Tesla and Graviticov and a couple others. And he mishmashed all of these ideas together into the Graviflyer. He went through a lot of iterations. It actually took him over 10 years to come up with the final form of this thing that he could get to lift fairly reliably. It usually takes him about 3 tries on average, with about an hour-ish per try, but he can still reliably get it. He did a live demonstration over Zoom in front of me and some colleagues, and we saw it happen multiple times over multiple Zoom calls. He was able to get the thing to do the tip over thing that he did in his garage, and then finally he was able to get it to do the lifting thing. So we've seen this thing work, and you know, he points the camera up and he shows no strings, no nothing, right? So we're 100% confident at this point. This thing is not a scam. It's not, you know, anything that he's pulling the wool over people's eyes. He's never like advertised to sell these things. The only Graviflyers kits that he's put together that he has sold to people, people had to beg him for that kit. So he's only built like, I think maybe 6 kits altogether. Also, he said that somebody in France was able to successfully reproduce this. We haven't been able to find out who that was. And then word on the street is that a team in Australia has also managed to successfully reproduce this effect as well. So I'm not first to the party here or nothing. I'm just, you know, going off of what other people are saying. So now for the operations of this thing. So you have let me turn this thing off. You have 2 counter-rotating discs. The top disc, as looking down, is going clockwise. The bottom disc is going counterclockwise. There are 6 neodymium magnets on the bottom here that are all equally spaced, and they're all positioned right flush with the edge here. I'll just keep going from the top down. So at the top here, we have an ultrasound piezo buzzer. Then we have this clockwise spinning disc that gets charged positively to about +5 to +10 kilovolts. Then we have this center disc, which is stationary, which is twice the diameter of the spinning discs. That seems to be an important component. And then on the bottom, counterclockwise rotating disc, it gets charged to -5 to 10 kilovolts and has these magnets that are facing north up. So you follow that right-hand rule, you got north up, you got counterclockwise rotation, and you got a negative charge. And so all 3 of those build together to like contain the ions, to build up the extra charge. It basically just ends up meaning that this eddy current that is developed from the rotation, the moving of these magnets, that this eddy current ring that starts in the center disk here, it ends up being a stronger magnetic field than if it was spinning the other way, or if it was north down, or if it was positively charged, right? So I've tried all of those different things just to, you know, verify, but right-hand rule for the win. Let's see. So what gives me hope about this thing? Well, for sure, seeing Alexi lift the thing live multiple times over Zoom calls, like I was pretty reserved. Like as I've been building and testing this thing for about the last 2 years, I've repeatedly confirmed like 10 to 20 different little things that Alexi says that you should see or observe during your testing. But lift hasn't been one of them. But seeing him be able to lift it, being able to see it live with my own eyes like that, right there, that was the moment that I went from like 50 to 60% sure that it was legit to like, no, this thing's 100% legit. I just have to, pick the lock, as Alexi says, because you got all these different tuning things that you have to do that I'll go through in just a second. But the parameters, so many interacting variables here, and it's a very non-linear, chaotic system. That's just right on the edge of order, right? So everything has to be perfect. So like Alexi says, it's like picking a lock. You have to get every single one of those pins, every single one of those variables just right. You have to have the spacing of the discs proper. You have to have the voltages proper. You have to have the frequencies of everything proper. It's a lot to balance. Oh, and then just for the sweetest part, at the very end, the very last step that he does to make it lift is on the ultrasound circuit here. He's got this little button that is normally closed. So you push this down and it opens this circuit, right? It turns off the ultrasound. Well, it doesn't just do that. It's got a ferrite torus core in there with a bunch of windings. And so when you quickly push that button, it releases all the stored energy in that core, which results in an EMP from that piezo buzzer, which like does a field inversion or something. All I know is that I had knocked out my electronics multiple times, and it may happen today. I haven't tried live streaming while testing this, so if the video feed cuts out, I guess that's good proof, but I will try to start the stream back up as quickly as possible if that occurs. Let's see. Oh yeah, TT Brown effect. So I actually tested this to see if it was like the TT Brown effect. Let me grab some things. So TT Brown, you got curved domes, right? And one is much larger than the other. So what I did was I took, let's see, here it is. I took one of these guys, one of these symbols. I drilled a bunch of holes in it to put the magnets on it, right? I was trying to kind of change it to be like TT Brown, but still like the Graviflyer, right? Mishmash of the two. So anyways, magnets. And then the top one, I think I put like one of these really big ones, right, on the top. And I had, let's see if I can pull this other thing up. For the center disc, I cut out this big piece of high density polyethylene or polyurethane. It's like HDPE. It's super insulative, right? Really high K dielectric, which is important for the TT Brown thing. So this was the center disc. Those symbols were spinning, and those were like the TT Brown domes and stuff. And I cranked my high voltage up to as high as it would go, which is like 35 kV. And I was measuring, I don't think you can see it on camera very easily. So you got a weight scale that the Graviflyer is hanging from. I was measuring, and I was able to, with this scale, I can measure down to like 20 milligrams, which, I mean, TT Brown, if you're talking millinewtons or less, right, that scale ain't going to pick it up. Anyways, I didn't note anything at all. No changes whatsoever with all different configurations of TT Brown-esque on this. One other thing about the TT Brown thing. So according to his stuff, it's like the effect doesn't even really start until 50 kV. And to even be useful or noticeable at all, it's like 150 kV, right? And that's with dielectrics with a K constant of like 8,000, right? Which the HDPE stuff is like dielectric constant of maybe a dozen, maybe 20 or something like that. Like it's not that high. It's not like designed to be a supercapacitor kind of thing like the TT Brown thing is, but that's the TT Brown stuff. Not saying that there isn't something to be had for the TT Brown stuff. I mean, I totally think there's something there. It's just if you want to generate 250,000 volts consistently enough to keep charging up your domes and stuff, you got all sorts of headaches that you're dealing with. And yeah, anything above 30 kilovolts is just a pain in the butt to deal with because you got all these coronas, all these arcings. You got a ton of electromagnetic, electrostatic noise going on. It wants to knock out all your electronics. Like it's just a pain in the butt. So right now, as far as checking out the fields on it, we have hired someone who is a pro with COMSOL, which is a finite element modeling software. It's a physics modeling software. This guy is the same guy that did the modeling for the M drive back in the day. So like he knows what he's doing. And thus far, he seems pretty convinced that a ton of the operation of this comes down to the piezo buzzer, because there are certain vibrational modes that occur in that buzzer that seem to really amplify these transients, these EMPs, these sharp rise spikes that we're getting. So hopefully I'll know here in about a month or less the final results of his modeling, because I'm hoping that that's going to really narrow down the frequencies that we need to be focusing on for the ultrasound, as well as the amplitudes, along with how that interacts with all these other fields going on. So how about I just start going through yeah, I wish I could fly Alexi out. So yeah, my team, we were talking with Alexi fairly regularly from like December to February, right? And it was during that time that he built another Graviflyer in order to do live demonstrations in front of us. And he was answering our questions, and it was glorious. It was everything I'd hoped for this far, right? And then he's like dropped off the face of the earth as of like a month and a half ago, sometime mid-February. I think he might have gone back to Russia. He might have, moved somewhere else. We don't know. We can't get a hold of him to save our lives. And we have most certainly continued every day. We're still trying to get in contact with him, but it's looking like he has gone incognito mode, which is not unusual for him. He's done that in the past. We would email him questions, and he would like take a few months to respond, and then he'd respond to everybody all in the span of like a week, right? And then he'd go incognito mode for another few months. I think that's just in part his job. He's got a job where he like travels a lot doing like media tech type stuff, I guess. I don't know. So frequency, are you trying to match each component or trying for an octave approach? Ooh, that's a good question. So how about I just go through the frequencies? So these discs are spinning at somewhere between 12 to 35 hertz, right? That's like, 600 to 2000 RPM, in that ballpark, right? But I'm going to keep everything in hertz. So like 12 to 35 hertz. And then you have 6 magnets on here. So multiply that number by 6 for the speed of that eddy current, right? That eddy current has these pulses going through it. So it has a frequency itself. So that's up in the range of like, 100 to 200 hertz. I think I measured it at the highest when I was really spinning these things. The highest I've gotten the eddy current speed was like 450 hertz. And then you have what's the next one? I'm trying to go from lowest frequency to highest frequency. So you have the speed of the discs. Then you have the ultrasound would probably be the next one. The ultrasound, you're operating outside of the audible range, according to Alexi. So that's anywhere from 20 kilohertz up to like 150 kilohertz. The circuit that he has provided, this is a circuit that circuit diagram, built from the circuit diagram he provided. This thing goes to about 40 kilohertz. But in his videos and in the live Zoom calls with him, we had him put a meter on the thing to see about what frequency it was, and he thought it was around 91 kilohertz, which is interesting. The console guy has shown that in the 45 and 90 kilohertz ranges, you get like 6-fingered membrane modes and 12-fingered membrane modes on that piezo buzzer. So there's probably some kind of there. The next one is the high voltage, which is coming from a flyback. That is operating at between 38 to 40 kilohertz of pulsed DC. The next one after that is on the center disc here. I have this wire that is going down the throat of the Tesla coil. So it's capacitively coupled inside the Tesla coil. And then this rod is not insulated from the center disc, just like Alexey's is not insulated. So this center disc is operating at the Tesla coil frequencies, which are a lot of harmonics. You get like 360 kilohertz, you get like 750 kilohertz. The one that Alexey said that he thought was the main one was about 1.2 megahertz. Right now, my Tesla coil is set up for closer to 1.38 to 1.4 megahertz. And then you have higher harmonics from that, so like 2 megahertz, 2.8 megahertz. In fact, how about I just turn that on and zoom this down so you can kind of see a little better. Oops. All right, so on the spectrum analyzer right now, set this down to the lower end. All right, so this is a start frequency of 0 hertz, a stop frequency of 5 megahertz, and the first peak that we see is 745 kilohertz. The next peak is 1.49, 1.5 meg. Let me skip that one, killing me here. There we go. The next one is 2.24 meg. Oh my God. Killing me here. Next one is at 3 meg. So what's really interesting is all of these harmonics that you see from the Tesla coil, the ultrasound also produces a lot of harmonics as well. One thing I can do to show that off is, all right, so now it's at max hold. So this is kind of like the noise floor, right? Nothing's going on. Turn on my ultrasound. Now, as let's see if I can get this. So what should happen, especially as I get towards the top and bottom end of this thing, the amplitude goes way up. Come on. It's like a 10-turn pot, so it takes a long time. There we go. So now you can hear the ultrasound. And actually, I need to increase the frequency because most of these spikes seem to occur somewhere between 7 to 12 meg. All right, let's do the right max hold. There we go. All right, so ultrasound is off. Let that settle for a second. Turn the ultrasound on. You can see we got all of this noise up here when I turn on the ultrasound. And that noise is like the bottom of the start of the ramp is 7.45 meg. The end of the ramp is 8.77 meg. And like the peak is around 7.75 meg. Oh, you gotta love that sound. Anyways, but it doesn't really change except when I get down there towards that very bottom and it starts freaking out and glitching out. That is all those transients. You can see over here, this pink line that I have going. See if I can make that a little more visible. There we go. So I can turn that down by turning up the frequency. And you can see the amplitude. This is 60 hertz, right? This is a wall noise. I'm really talking about the thickness of the line itself, which I can zoom in to show a little better. Let me fix that. Get that thing a little more stable. All right, so now as I turn it down, you should see it get much thicker. See that? And over on my power supply, you can't really see the numbers, but I have it limited, so it's 5 volts constant with a max of about half an amp. And when I turn that ultrasound all the way down, that's when my power starts going way up. It starts drawing a ton of power, probably because the resistor on this circuit is dumping a lot of juice, even though that doesn't get warm. I don't know. Anyways, what I'm really trying to show right now, though, is all of these transient spikes over here. So when I get this guy nice and fat, see all these transients. Oh, you see those ones up there? So what's happening is when I break the circuit by pushing the button, that ends up releasing all the stored energy in that ferrite core, which releases an EMP. So the faster you can push the button, the faster you can break that, the shorter the amount of time it'll take for that core to dump its juice. And power over time is quite important, right? If you want to expend a joule in a second versus a joule in a nanosecond, you convert everything to joules per second. So if you unload a joule in a nanosecond, you're talking about gigawatts, right? So this thing, I did some calculations with it, and I think at most, its EMP is like in the high kilowatts, potentially, which would definitely be enough juice to invert the fields of that thing once they're all set up. Anyways, I'll turn that off. Let's see. What have I missed? Oh, yeah, and so frequency matching. So what I've tried to do, I've tried a bunch of different things for frequency matching. One thing I've done is I've created this huge spreadsheet of just a ton of variables. And I highlight all of the boxes, all the cells where the output is like an important dimension, right? So I convert everything from frequency to wavelength. And then if the wavelength happens to be equivalent to the thickness or the diameter or the spacing of any component or any ratio thereof, then I highlight that cell. And when I have a whole row of things at a certain frequency where everything's lining up, that's where I know that that's probably a good place to start matching stuff. So I've used that to kind of ballpark guess what my spacing should be, what my diameters should be, what my ultrasound frequency should be. And it does an okay job for getting me close, but, little tweaking. So if it says, you need to be at 27 kilohertz for the piezo, it might be 26, it might be 28, but it's going to be in that window. Yeah. High volume 96 to here, beat frequency. So, okay, so there is a software that I've used that I show in some of my videos called Spectrasizer. It was just a free audio analysis software that I found. And with this, I think I have a 44 kilohertz microphone, but the software can only go up to like 22 kilohertz. That is a great idea for the higher fidelity. I've looked into ultrasonic microphones, and I just haven't pulled the trigger on that yet, but I think it would be really good. Part of the other problem, though, is that you saw how this amplitude goes way down. The volume drop off from the audible volume of the ultrasound picked up by the microphone, like it drops off by 20 kilohertz, which tells me that this thing is not dealing with ultrasound waves in air, which already get attenuated to high heavens when you go above the ultrasonic range, right? You got to be a lot louder to be the same volume. You got to expend a lot more energy to be the same volume when you get higher and higher ultrasonic frequencies. So, and this thing is producing less and less energy at those higher frequencies. So I really don't think that it has anything to do with ultrasonic standing waves. That said, there are certain spacing combinations where you get interesting harmonic audible tones that come out of this, anywhere around 400 hertz, 700 hertz. Last night I was getting ones around 1800 hertz. There may very well be something there, but that might be the vibration of the center disk there, as it gets closer and farther away from each of the disks, the overall capacitance and impedance between those is oscillating, right? And so now you have a constantly changing thing against a constantly changing thing. That's a very nonlinear chaotic system. That very well could be part of the important components for lift, but I am not entirely certain on that. As of right now, especially with the piezo buzzer, it's really seeming a lot like it's electrostatic. So the magnetic field and the electric field being 90 degrees to each other. Yes and no. So it turns out when you look at the old school UFO stuff from like the 50s and 60s, and you go through those documents, a lot of what it seems like they were trying to do was they would actually bring the power factor to zero. Like they would take the 90 of the electric and magnetic, and they would bring it all the way down to 0 degrees. So the electric and magnetic were going in the same, direction, which is extremely inefficient. But that's what the old saucers were doing. I don't get it. It might have something to do with like a curled pointing vector or something. I don't know. I have no idea what they're doing, but that is what they're doing. An anti-capacitor button. Anti-capacitor button. So you can think of the piezo buzzer like a capacitor. I've actually gone through and I've measured the resistance and capacitance of the piezo buzzer through the whole frequency range from 0 to like a megahertz. And its capacitance like starts high at the low end of the frequency, and then it dips down, and then it starts coming back up around 100 kilohertz. It gets back to the same capacitance as it was when it started, and its capacitance goes up higher and higher and higher as you go higher and higher and higher. So my thinking is there's a matching that you're trying to do. There's a capacitance value for the disks to the center disk, as well as the disks to each other, and then you're trying to match the overall capacitance of this system to the capacitance of this guy, which is determined by the frequency of this guy. And yeah, the capacitances that we're dealing with, though, is extremely small. I wrote it down my whiteboard, wherever that went. But it's like in the nanofarad range, like 25 to 50 nanofarads. Was it even in the picofarads? I gotta find. Oh, there's my whiteboard. All right, so the top disk, when it's at about 30 millimeter spacing, I got about 40 picofarads between this disk and the center disk. And then between the bottom disk and the center disk, when it's at 25 millimeters, I got it at 47 picofarads. The Tesla coil and mid plate, I measured the capacitance of that system, and that was sitting in the ballpark of 35 to 40 picofarads, which changes a lot depending on the depth of that wire down the throat of the thing. But it is what it is. Let's see. Oh, Jeremiah, you made it. Cool. I feel like you have to see the field in your mind. I understand. I hear no mention of torsion. Yeah, torsion. Blech, torsion. So Alexey, he is all about that torsion. Torsion physics is huge in the anti-gravity field of the Russian side of things. I just can't. There might be something there. I can't get my mind to get into that mindset, because when you read papers, the white papers on torsion physics, like the values that they're talking about are just gobs of orders of magnitude more than anything here. So they're talking about torsion of, a Newton for something that, is a micro black hole. And here we got something that is 15 orders of magnitude less powerful than that micro black hole. So we're not, and we know that we need like at least 10 Newtons to get this thing off the ground, right? Torsion. Anything has to do with no point of the magnet? Okay, so that's a good question about the no point of the magnet, Tim. So he's saying, does anything have to do with no point of the magnet? So the spacings of these disks is just, oh, it's such a pain in the butt. So the distance of this bottom disc from here, these magnets from here, right? When these spin, you create an eddy current in this in this center disc. That means that as this thing gets farther and farther away, it experiences less drag from that eddy current, right? Well, that eddy current creates a secondary eddy current in this top disc. So that means that the speed and distance of the bottom disc is affecting the top disc. And of course, as the top disc gets closer and closer to that eddy current, that means that secondary eddy current is getting stronger and stronger. So it fights it there too. So that right off the bat, you got like a three-order nonlinear system setup going on. Not fun. So there are certain null points where if you get this, and this is something I just found out last night, guys. The spacings of these disks will determine how fast the disks are able to accumulate charge, as well as how the top disk's speed is affected by the accumulated charge. So I've been testing at farther spacings, about 35 millimeters plus for the top and the bottom. And up until last night, when the top disk accumulates more and more positive charge, it will start to slow down. So I'll start at like 21 hertz for the top. And by the time I'm done with the high voltage and it's got all the charge it's going to get, it will slow down to like by a half a hertz. Call it a half a hertz, anywhere from 0.2 to 0.8 hertz, somewhere around there, right? Well, last night I started playing around with much closer spacings. And wouldn't you know it, it inverted what happens to the top disk's speed when it's getting the high voltage applied. So the top disk, now instead of losing speed as it gains charge, it's gaining speed as it's gaining charge just because of the spacing change, nothing else. So that's hurting my brain a lot because that means there's totally null points in here where like just above or just below is going to affect what happens to this thing for charge. Additionally, the charges on these disks at the farther apart spacings, it always seemed like this bottom disk gained negative charge a lot faster and a lot higher maximum when it was farther away. Now that I brought it closer, it charges slower, it gains charge slower, and the top disk is now able to gain more charge. So the top disk was topping out at like maybe plus 3 kV with my static meter, which is right here. Got one of these static meters that I use to give me a ballpark reference for the amount of charge on the surfaces of these disks, or how charged they are, I should say. Anyways, yeah, so this top disk, it's charging at, it's getting to higher charges and it's speeding up when it gains those charges when you get it closer and closer. And then there's some switch point for distance for the top disk where it will now, well, for a combination of the top and bottom disk spacings, there's some switch over point where the thing will gain less positive charge and will lose speed with that gained charge. So that's kind of where I'm at testing now, is trying to identify what exactly is that distance. Let's see, catch up on questions. Do you think you're chasing a fine tune because the power supply is not enough to produce the needed power to lift? No, not at all. So for the first year and a half of this thing, I was all about more power. But looking at Alexey's setup and his designs and everything, like, he does not use a lot of power. He's using like 6 watts for the motors, 12 volts, half an amp for both motors together. And then for his Tesla coil circuit, he's using like 12 volts, 1 amp max. For his ultrasound circuit, he's using like 12 volts, a quarter amp max. You could probably get this thing to fly if you knew what was required to make it fly. You could probably get this thing to fly for in the ballpark of like maybe 50 watts or less. And, you know, just one of my power supplies can put out 50 watts. So, yeah, it's not for lack of power. Oh, Jeremiah is saying, see the twist, see the spinners. Yes, yes. So there are these, that reminds me of something. So we have a physicist in the group, and he has been looking into these things called Hopf. So Hopf vibrations, H-O-P-F, Hopf vibrations are a theoretical physics thing that's basically talking about nested, twisted fields. At the smallest possible, you know, fundamental level. And then you have these things called solitons, which are solitary waves, which just go through a media unimpeded, right? And they don't really interact with other solitons. And there's a buttload of cool stuff about solitons. But anyways, he worked with, he had a colleague who looked into these things called Hopfions, which are Hopf solitons. So think of all the twistiness of the Hopf vibration combined with a packet of energy that's moving through a medium, and now you might be onto what is going on with this thing. That is a super esoteric physics-y explanation, which I'm hoping is not going to be the thing. I'm hoping the thing that is the cause of lift for all this is going to be some electrostatic, electromagnetic, proper field interactions. Because if it is more complicated than that, this thing is a piece of a junk-looking thing made in a garage out of like sheet metal and stuff. And you're talking about Hopf solitons and no, like there's no way that something so simplistic is doing something so complex. In my mind, something so simplistic is doing something simplistic. Sure, it's got very nonlinear interactions going on because it's got a lot of different parts, but it's still, at the fundamental level, a simplistic electromagnetic interaction with an electromagnetic interaction mushed together and twisted up and whatever. But getting down to like fundamental physics stuff to try to explain this stuff, ooh, gives me a headache. Let's see. You can use light instead of the ultrasound. Aha! So that's actually a really good observation, Dan. So the piezo buzzer here is creating an EMP, right? An electromagnetic pulse. Well, electromagnetic, that is light. It's not visible light, but it's light. When you look into electromagnetic pulse documentation out there, you will find a lot of SDI, Strategic Defense Initiative, Star Wars stuff from the 80s, where they were trying to get these lasers that would pulse super fast and hard. And so they were talking about these gigawatt lasers. Well, like I just said earlier about its energy over time, they were 1 joules. It's just they were finding ways to be able to release that 1 joule of electromagnetic energy in a coherent beam faster and faster and faster. So eventually they got it down to like sub 1 nanosecond. So gigawatt lasers. And I think the firing rate, you know, if you want to have that firing rate higher, it just takes a long time to charge up the capacitor bank for all that. But yeah, light instead, if you want to do a laser pulse. The problem is that it's like a poor man's laser, this piezo buzzer. It's creating the transient. The rise time of the transient is like super fast, like 50 to 100 nanoseconds. And the lifetime of the transient is like 200 to 300 nanoseconds. So it's dumping a lot of juice. I just don't know. Yeah, I don't know. Let's see what else we got. I'm hearing a helicopter. I live right next to an airport, so. Burst disruptions. A sonic resonance of the physical materials involved holding. Yes, Mr. Foster. That's an excellent question. So that spreadsheet that I was mentioning that I made, I was going through and using the speed of sound in aluminum as well as the skin depth for these AC frequency, these high frequency signals, right? I'm using the skin depth in aluminum. And then I realized, well, I got these steel rods of a certain diameter. I better include those as well. And, you know, the length of these rods. So yes, the material characteristics of this are very important. Another aspect that I've looked into, if possible, is that the vibrations as well as the electromagnetic frequencies that I'm dealing with, it's possible that I'm actually have an oscillating conductivity value for these disks that are vibrating and also have high, fast oscillating charges on them. And when you have a varying conductivity value, now you can start getting interesting interactions as the distances of these things is changing back and forth. Let's see. So right now, what I'm held up by, yeah, the tuning. It's all about that tuning. So like I was saying, there's like these null points and there's these spots where the spacings of these things is really important. Another thing is that the reason why it takes Alexey on average 3 tuning attempts each time is because he's not using any equipment. He's doing it all by ear, which the man is a savant of some kind to be able to do that. 2, he talks about how he has to catch the special sound that he starts to hear when it's ready to take off. He has to catch that by pressing the button. And the way that he presses the button, he has a method to pressing the button. But I can show you here on the screen what happens when you press this button. See if I can zoom in more. So you can zoom in even more and fix that so it's not so jiggly. All right. Can you see that on the screen? You can kind of see that on the screen, except that I got this wire in the way. How about now? That's a little easier. All right, so now when I press the button, there we go. You see I get a bunch more spikes, right? So that's the button pressed down. Well, if I zoom in even more, or actually zoom out a little bit, you should note that these, let me tune that up a little bit more. So all of those spikes, they kind of compress. It's changing in frequency, and it's going up in frequency the longer I hold it down. So there is a sweet spot amount of time to hold down this button when you press it. So now I don't even know whether or not it's the quick little tap to get the high transient pulse, or if it's a press and hold to get it to sweep through certain frequencies in order to have frequency interactions going on. Let's see. Really raising the altitude. Mr. W, that's a good question. So he's asking, what does Alexey do to make the height of the thing go up and down? He said that it was adjusting the ultrasound. So the ultrasound and the Tesla coil are intricately tied. You can't tune the ultrasound without simultaneously tuning the Tesla coil. But he said that it was increasing the frequency of the ultrasound is what made it go up higher and higher. However, I don't necessarily know that that's correct, that it was increasing in frequency. It could be correct, but based off what I'm seeing on the scope, how when you turn it way down, the amplitude goes way up. Well, increased amplitude means increased height in my book. So on this knob, it starts out at it's a 10-turn knob. It starts out really low frequency, and then it goes up farther and farther, and then you get nothing for like 8 turns until you press the button down. If you press the button down, you can still get transients, but that's besides the point. So you keep turning it, and then once you get to the other end, there's a flip over point, and I can look at my power supply here to know where I'm at in that flip over point. Okay, so I flipped over it, and I'm going down in frequency. I'm still turning it the same direction, but now I'm going down in frequency. So it's possible that Alexey reaches that point, and as he thinks that he's turning it up in frequency, he's actually turning it down, right? So I kept turning that the same way the whole time. So now I'm at the full other end of this pot. So not 100% sure what he's doing with the ultrasound. He thinks that he's increasing the frequency. I have found it is usually safe to not doubt Alexey when he says something. He is not great at explaining himself, but he is usually pretty spot on with his observations. So if he says it's going up in frequency, it probably is. It's just I can't verify that yet because I haven't got it to lift. Yeah, so auto testing, that is on the to-do list. Part of the issue with the auto test, though, is you have to know what you're looking for. And we still don't know 100% certain what that special sound that Alexi is listening for is. And until we know what that is, we're not going to be able to program the Arduino to catch the special sound by, closing circuits or changing speeds or changing amplitudes of things. Like, we can't get it to go through all those permutations until we know that key ingredient of the special sound, which he describes as the sound of a fishing reel unwinding. I get plenty of special sounds off of this thing, but without confirming with him by sending him a video, hey, this is the sound. Is this the sound you're talking about? Without that confirmation, it's a lot of trial and error. Like I said, it took him 10 years. So Jeremiah is saying PWM Burst Disruption of the Tesla coil and the ultrasonic in phase. Ooh, I like that. You want to build me that? I like that idea, man. I don't know how I'm gonna. I got an idea how I could make that happen. Yeah, that would be really interesting. I think when you press down the ultrasound button and you get the transient, that transient is like it's being picked up from the piezo all the way down through everything electrically below it and around it, right? Which means that it eventually feeds back and gets picked up at the Tesla coil. That's actually what I'm reading on this screen right over here. I have a 10x probe that is connected. One end of the probe is connected to the bottom of the primary. The ground clip is connected to the top end of the primary for this 10x probe. And that means that when I'm pulsing this ultrasound button, I am picking up these transients off of the Tesla coil primary, which is, so many steps removed from that piezo buzzer. Digital music tuning app and annotate the frequencies for each part of just having them suspended on a string. So I actually did that. What I did was I took these piezo buzzers. Let's see if I can grab one. So what I did was I took a piezo buzzer. I taped it down to the center of one of these discs. And I took another piezo buzzer and put it on the opposite side. And I would do frequency sweeps through the input one and register the amplitude of the receiving one. And so I was able to identify all these different vibrational modes of the stuff. However, this thing has variables. So one of those things is high voltage. Another one is centrifugal force. And then another one is the eddy currents. So all of these things change the musical properties of these metal plates, which means that if you're spinning a highly charged thing, you can think of charge kind of like stuffing sand into a sponge, right? You're getting all these electrons shoved into all the holes and everything, and it becomes stiffer. And then the centrifugal force off this thing, once again, making it stiffer. So and the eddy current, you got a little bit of work hardening in there, which is also making it slightly stiffer and more brittle and tinnier sounding, along with the thermal stuff, which is softening it. So you got variables 15 ways from Sunday that are making this these musical resonance notes change during operation, which so frustrating. What part of the Graviflyer supports its own weight while in flight? That is a good question. So I have analyzed every single one of Alexey's videos pixel by pixel. it has been an arduous task. But from what I've been able to determine, when this thing lifts, the speed of the bottom disc initially drops, and then it comes back up and kind of overshoots and then comes back. So there is some gyroscopic interaction there, but I don't think it's much because it's only dropping by like 60 hertz, and it's a fan motor, PC fan motor, so not a lot of torque. So that's just the act of, this thing actually like producing thrust and going up affects the speed of that a little bit. What I've seen, though, is it looks like the arms itself. I swear there's one of his indoor videos, I saw what looked like a single frame where it flexed that part up. Let's see if I'm showing that right. You can't really see that well. This spot right here, it like flexed up right there, which means that this thing was producing lift somewhere around these struts. Either this thing is lifting up, but I didn't really see the edges of the disc lift up. Or, the piezo buzzer is somehow getting pulled upwards, right? Which I strongly suspect that the piezo buzzer is my own suspicion. I suspect the piezo buzzer is the focus of lift. That is where the majority of the lift is actually occurring, is at that buzzer. Because when you watch his videos and it looks like it's being held from a string dead center, and like even when there's wind, it still looks like it's being held by a string from the dead center. Well, that's because this piezo buzzer's diameter is so much smaller than the diameter of everything else. And all of this has to be perfectly centered to the disc. If you have these spinning discs at all off-centered from each other or off-centered off the center of this disc, that's when you get the tip-over thing, or you'll get some weird like gyration, wobulation stuff going on. So yeah, I really think that the piezo buzzer is the magic. Which, speaking of, here's another thing I did. So I got all of these 3D printed pucks that I made. I'm showing this well. And so I got 5 piezo buzzers all sandwiched and stacked up in here, and then I had these all set up in there. I was testing with that for about a week. But the problem is Alexey only used 1 buzzer. And when I was using these 5 buzzers, the volume was much louder. The output was way better. But the problem was the output was a little dirtier because each of these piezos is interacting nonlinear with its neighboring piezo, which is not ideal. We have enough nonlinearities in the system as it is. I went back and I just put 1 piezo in there while I continue to test. But I might go back and try the stack of piezos thing again. It might also be that creating, like a pyramid of piezos all around the thing, that might be it. I don't know. But what I'll call it 60 to 70% certain at this point, is that the piezo buzzer is the point of lift. Oh, and I am absolutely keeping records of what does and doesn't work. I have many, many gigabytes of video testing, and then I also have this engineering journal thing that I'm using that, I'll try something, I'll write it down in here. I'm documenting my stuff every single day. I don't share what I'm doing every single day because I figure it's quite boring to most people, but I am keeping a record of everything that I try. Yeah. Oh, that's another good question, Dan. What if it needs to be on the ground first instead of suspended? All of Alexey's tests start at the ground. That's a great point. So we asked Alexey a while back if it would be okay to put like rubber feet on the bottom of this thing, because I was having a horrible time with my ears as this metal was just screeching on the concrete floor in the shop here from all the vibrations of this thing. Alexey said, no, it's very important. You do not cover the feet. You don't insulate the feet. The feet should be grounded. So what I have is I have a ground wire that from time to time I will wrap around there, and there, now it's all grounded. Part of the problem with doing that, though, is that the Tesla coil that's going to this thing, if you ground out this whole thing, then what the crap is that Tesla coil even doing? the signal is just all getting routed straight to ground. So that's one thing. Another thing is that I need to be able to look at this thing at eye level. When it was down on the ground, you know, you're hunching over, you're bending over, you're trying to see it all the time, and it's killing my back, and you got to make an adjustment to the thing. Just a pain in the butt. So as far as does it need to be on the ground? Probably. But I am not 100% certain that it does need to be. If it's not on the ground, then you end up getting a floating ground. And so that means that when I start measuring my voltages, my static charges and stuff, it'll start accumulating a net charge over the whole thing, which in my case is usually a negative charge. Usually I'm ending up getting about negative 1 to 2 kV off of the center disk there after I've been testing for a very long time. Okay, so turn. Possibly drive shafts in the motors are bearing the load. I don't know that that's actually the case because the amount of RPM changes you would expect to be a lot more for lifting this thing itself off the ground. Alexey is using PC fan motors, which have the tiniest of bearings in them, and it is really susceptible to any kind of wobble and grinding and on those bearings. So if this thing was actually experiencing enough force on that axle, on that shaft, to be able to lift the thing up, those bearings would be giving out like crazy, right? The equivalent that you could do to test it would be like to get a little wheel on a stick or a couple of them, and then as it's spinning, just push that up enough to make this thing lift. I mean, do you see how much that is? How much that flexes? You see how much flex that is? Yeah, ain't no way the lift is coming off the rotors. You would see that. When Alexey touched the Graviflyer, wouldn't it short out the Tesla coil? That's a good question too. So one thing you can do when you're testing your Tesla coils is you can use a little fluorescent bulb, put it next to the thing, and make it light up. If you have everything tuned right, according to Alexey, you should be able to get the lamp to light up from the edge of the Graviflyer, right? Because this is basically the top load for the Tesla coil. So there should be a decent distance there where it's putting out enough RF energy that you can make the bulb light up. Well, what you'll find with Slayer Exciter Tesla coils is that if you touch it, if you ground it out briefly, it will change which harmonic mode it's in. And then you got to like touch it again and reground it again. So eventually it can fall back into the original resonance mode that you want it to be in. So I think once this thing is up in the air and it's already flying, it's pretty darn resilient against a lot of things that you can do to it. I mean, for crying out loud, Alexey like drop kicks the thing with his foot, and then that, you know, it kind of wobbles a little bit and it just comes back. So once you have the fields inverted, once there's an inversion of the charges on these things or something like that, it can handle a lot without falling out of the sky. Okay, so Dan's asking, have you detected the orbs? I think Alexey showed orbs showing up around the device. Okay, so Alexey's orb video. It's, I don't remember the name of that video, but it's like indoors. He's got like a red filter on his camera, and you can see a bunch of what looks like bright dust particles floating around. And he claims that there's these orbs that you can't really see with the naked eye very easily, but you can pick them up on infrared cameras. I've never seen those orbs. You know, when it comes to camera artifacts like that, like, you got to be a lot smarter than me to know what is legit and what is erroneous of some kind. I don't know about the orbs. It's possible. One of our team members is really keen on the Martin Fleischmann project, the EVOs, extraordinary vacuum objects, I think they're called. And he thinks that those things might very well be getting produced, which is possible. When I say EVOs, for those who don't know, think ball lightning, but teensy tiny ball lightning. That's the gist of it. So the brushes, especially on Alexis, those brushes for the high voltage are made of brass. So you've got scraping occurring, which means you got these charged metallic shard ions all over the place. Maybe there's anti-gravity in those things. I don't know. How about I spin this thing up and you guys can see what the process looks like, and I will ask for inputs somewhere along the way. So let me clear that. Unzoom this so I can see my speeds. All right, so step one, you turn on the rotors. You get them spinning up. Now, because this is my first live stream, I'm not set up well enough, but I have a lab view program that lets me watch the speeds of my discs over time. And that's where it gets really useful data there, because you can see that it takes about 3 to 5 minutes for the eddy current produced by these discs, as well as the wobbles and everything, to kind of like even itself out. So the whole thing will start, slow, it'll speed up, and then it'll kind of stay there, and then it'll kind of oscillate in speed. And then eventually it might like creep up just a little bit, and then it'll get steadier and steadier. And after about 5 minutes, you're good to go. It's also worth mentioning, Alexey has given a lot of different RPMs to test this thing at. So originally he told us bottom rotor 2,000 RPM, top rotor 2,500 RPM. Or I might be misremembering that. It might be 2,500 for the bottom and 3,000 for the top. Either way, his PC fan motors, we've measured them. They don't go faster than 1,800 RPMs. And they get worn out pretty quick because, like I said, bad bearings. And in his video, one of his most recent outdoor videos, where you can see the bottom disc slow down some, it's matched pretty well to the frame rate of the camera, because it looks like the magnets are stationary, right? Not moving. You got that spectroscopic effect thing going on, where something's moving at the same rate as the frame rate of the camera, so it looks like it's standing still. So using that, I was able to determine that the bottom rotor was spinning in the ballpark of either 1,200 or 1,800 RPMs. Thermal camera. My buddy Charles has a thermal camera. He has used it and observed some heat generation on the top 1/3 of the Tesla coil, but that's about it. Nothing really with the Graviflyer, other than the motors getting kind of hot. All right, so right now I'm spinning kind of slow. I got them going at 21 hertz for the bottom, 23 hertz for the top. So in the past, up until a couple days ago, actually, I've been running each of these motors off of a separate PWM controller. That is not how Alexey does it. I'm trying to go back to original Alexey. Alexey has it so both motors are coming off of a single power controller, which is probably pretty important, because that means that if you have a set amount of power going out of this controller and it's going to both of those motors, and then through all of your testing, the load increases or decreases on just one of them, that means you're going to have a change in the other one. That would not happen if you're using separate motor controllers. So it's probably pretty important to let the motors be dependent upon one another like that. Let that spin up here for another minute. Excuse me while I hydrate. All right. Is my audio coming through okay? Am I too quiet? Do I need to be louder? No, I do not control the humidity in my workspace. I don't even measure the humidity in my workspace, which is not ideal because when you're dealing with these high voltages, it's helpful to know what your breakdown voltage is going to be by knowing the humidity. Oh, good, good. My audio has been a little on the quiet side when I've been doing a lot of my video recordings, so glad to know that it's going okay. All right. I have let this thing kind of stabilize now. The next step is you turn on, first I'm going to get my trigger thing here so that you can watch the speed of the top disk. Oops. So you can watch the speed of the top disk change. Turn that off. Move this down a little bit. So unfortunately, that's not going to be as easy as I thought. When the speeds of the two disks is really close together, it's really easy to see minor variations in the speeds of the disks. I guess this might work. So you can see the blue line, which is my top, it's the top line, top rotor. We should see that speed up, so going this way even faster as I apply my high voltage. But it's going to take about 10 to 15 minutes because you turn on the high voltage, which I'll do right now. So high voltage. Ooh. There you go. So I'm at about 10 volts in, and already you can see how much stinking noise I get on there. Let's see if I can make that a little cleaner for you. Godfrey's asking, how do you know which way to rotate the discs? Right hand rule, bruh. You got north facing up and negative charge on that bottom disc. That means that it has to spin counterclockwise in order to follow the right hand rule properly. So on this high voltage thing, you turn it on to the minimum, which for me is about 10 volts in starting. And then the ending is 16 volts in. If I go above that, I risk arcing. And if you get a single arc, you've got to shut everything down and start over, according to Alexi. Anyways, you turn it on, you let it sit at one voltage, you let it start building up charge at one input voltage. And then you tweak and increase slightly the input voltage again. And so you got to creep your way slowly over the course of about 10 to 15 minutes up to the final input high voltage, which for me is 16 volts in, which corresponds to like, I don't know, something like plus minus 11 kV to each disc, right? So with the spacings that I have now, I'll probably get something like plus 4 to 5 kV on the top and minus 4 to 6 on the bottom. I'm of the mind that right now that it's probably pretty important to try to balance the charges on the two spinning discs. So if I move one of these discs much farther away, it's going to change that balance between the two for how much charge they eventually accumulate. So I can do a test right now. All right, so right now we're reading like 0 kilovolts per meter. You hold this thing 1 inch away, and that tells you the kilovolts per meter. So I hold this thing 1 inch away, and I'm setting it at minus 0.5 kV for the bottom, plus 3.2 kV for the top. So you can see the top is already gained a ton of charge really fast, and the bottom hasn't barely gained any. If we sit here for a minute, this might go up to negative 0.6, but it's not worth measuring that. You just got to slowly increase it. If I just put this thing straight up to the max negative 16 right off the get-go, that bottom disc will never reach, or it'll take just forever to reach its final resting voltage. There's something about slowly, incrementally increasing the input from the flyback that gets this thing to hold a charge better and better. We've asked Alexi to record the fishing reel sound, and in fact, in the live Zoom calls that we recorded, that we haven't shared with folks yet, you can't hear it. It doesn't come through over the microphone. All of the recording software out there, it filters out noise, right? Well, it registers that sound as noise, which means that we haven't been able to hear it. Very frustrating. Alexi said that he was able to, using a used old car battery, that he was able to run this thing out in the field for like, I think it was like 30 minutes, maybe it was a couple hours. He ran it for us. He ran it with everything plugged into the outlets of his house. So we know that it can operate either way, either all of a single power source like a battery, or everything plugged into the grid. Turin's asking, if the machine is dependent on the Earth, then how could it work in space? So if you say it's dependent on Earth like it's dependent upon Earth ground, you got satellites up in space all over the place, and they have their own ground, right? An artificial ground. So that's not really a big concern there. As far as other things, like does it need to rely upon air, the medium of air somehow? I don't know that that's necessarily the case either. It might be that it needs to have some kind of medium, in which case then you just enclose the thing and you have an artificial atmosphere inside the craft itself. And assuming that, it's using these electromagnetic, electrostatic fields to produce thrust, and it just needs that medium in order to make that happen, then it wouldn't be a problem to have an enclosed artificial atmosphere thing, right? If it does end up being that somehow this thing is pushing air or pushing ions, or a reactionary thrust type model, in that case, then yeah, space might not be the answer. But it's worth mentioning that the most expensive state-of-the-art ion thrusters out there today, they have they cost like $100 million, and they're producing 1% of the thrust of the Graviflyer. So the Graviflyer, if it is an ion thruster, which I don't think it is, but if it was, that means it's producing 100 times more thrust than $100 million ion thruster. That does not sound plausible to me. I'm sorry. That is absolutely silly. Those expensive ion thrusters have a lot of technology and a lot of smarts put into them to absolutely maximize every possible, millijoule of juice you're going to get, millinewton of juice you're going to get out of that thing. This thing is a garage build, man. I'm using phantom powered, but I am not using, maybe I'm using, I don't know. It's a USB-B, the big square guy, but normally the phantom powered ones, they have like a little DC plug in them as well, right? This does not have that. Dan, he was able to get the thing flying out in the field multiple times, like maybe half dozen times. He flew it out in the field with the car battery. And since we saw it takes them a couple hours of tuning to get the thing, tries for the tuning to get it to lift. Increase this voltage. Right now I'm up to 11 volts in. It took him a couple of tries, a couple of hours each time. So I suspect the car battery, it probably lasted just fine, especially if he's only using like 100 watts, right? I mean, a car battery is probably going to be able to supply, if it's like a 20 to 100 amp hour car battery. I swear I looked at one of his videos way back in the day, and I thought it was like a 20 or 30 amp hour car battery. Like, it wasn't very big. Which, I mean, if he's using everything 12 volts and like, 3 amps altogether, maybe 5 amps altogether, that's like 6 hours of tuning time. So yeah, I suspect no problems using car battery. Have I roughed up the discs with sandpaper to get it to hold charge? I have done that. Let's see if I can show one here. I got one of my old discs around here somewhere. I can't find it now. I got one of these discs around here somewhere where I scraped it with a file and scraped it up really good. And I measured the before and after, and I got very little change. And then I tested the difference between this quilted orange peel aluminum stuff that Alexey says to use. I tested the difference between that and the smooth metal one. And there was almost no difference there. And then I got really ambitious. And I got some 2-mole sulfuric or hydrochloric acid. I forget which one it was. I think it's hydrochloric. Anyways, I got acid, and I took one of these things and I set it down in the acid. And I cooked it outside for like 2 days, and tried to see if that would increase it. It didn't increase it nearly as much as I thought. I thought I was going to get like up to 4 to 8x increase in capacitance. Nope. So now I've left one of those discs sitting in the corner back here in that hydrochloric acid for like 4 months. I want to take a peek at that, actually. Now that I'm talking about it, let me take a little peek-a-rooney and maybe I'll hold it up. Oh, geez. Well, this is the result of my hydrochloric acid. It is still in there. It looks like it's all decayed and everything. It's not. It's just covered in like white crystalline powder. I could get it out of there. It looks very smooth. But I'm not really interested in increasing the capacitance on the discs as much anymore. I think it has a lot more to do with balancing charges than increasing charges. Bom dia, Gabriel. Is the difference in the charge happen in the flyback coil or through the center disc? Is the difference in the charge happen? I don't quite understand, Nathan. The difference in charge. Okay, I think I understand, kind of. So as I continue to go through this testing, let me increase voltage again. Now we're at 12.2 volts in. What will happen here is when I do the pulse button, there will be a transfer of charge that will occur. The bottom disc will lose some of its negative charge. It'll go from like -6 kV down to -3 kV or something like that, or even less. And the top disc, I'm not sure what the top disc is going to do, but that's going to lose some. And then the center disc is going to gain some of that negative charge. So it'll go up from like, well, what's it sitting at now? Right? Right now it's at like 0. You see that? Right? 0.15. It's at 0 for the center disc. So when I do this pulse button, though, what's going to happen is with the Tesla coil on here as well, this center disk is going to end up accumulating negative charge to the tune of like -1 to 2 kV. Any ideas on how to control the XY axis of the Graviflyer while on flight? I do, actually. I think that when you look at Alexey's videos where it just tips over, that's really indicative that you can get this thing to do that kind of motion, which if you can do that, you can do any direction you want, right? I have a strong suspicion that part of that has to do with the position of the two spinning discs. If they're offset at all or off-centered at all, that's when you'll get like too much lift on just one side and it tips over. So it might be possible to have struts that just kind of move one disc, you know, ever so slightly in one direction. And now you create this offset, which causes it to tilt and go in a certain direction. Mr. W, why has nobody offered a giant wad of cash to Alexey for complete build of all items needed in test videos and have it shipped here with necessary settings? So that has been done. So Charles Crawford, who is my partner, who has a channel that you can find if you go to my channel at the very bottom. He's like one of 3 channels that I show on there. He has 2, not 1, 2 Graviflyers built by Alexey. And 3 circuit bundles built by Alexey. He actually bought 3 Graviflyers, but one of the Graviflyers ended up getting lost in the mail in between there and here. But 2 out of 3 ain't bad. So we've used those 2 to come up with all sorts of measurements to be able to successfully reproduce it. And before Alexey dropped off the face of the earth, we were Charles is doing a really good job building like very uniform Graviflyer kits, right? So there was variations between Alexey's different Graviflyers because he's building them out of junk. Charles, being the excellent engineer that he is, has standardized the kits. And so he's built a couple of those standard models now to ship out. We wanted to ship out one of those to Alexey and do like live. We're tuning it at the same time that he's tuning it, and we're all doing the same thing at the same time, right? But now Alexey is incognito mode. And then on top of that, like we knew where Alexey lived because we mailed him some cheap pieces of equipment like a multimeter so he could get some frequencies for us. And like we offered a lot of times, not just to, you know, fly ourselves out there and just see it in person live for like a day, but like we offered him money to let us do that. But he is a very private person. He doesn't like people, I don't think, even though he's a really nice guy. He's very, very introverted. And when you are very introverted, the thought of having a couple of strangers from the other side of the world come and into your house and stay at your house all day for a couple of days, I can understand why he might have been a little reticent about that. We also offered to fly him out here, but I think he has some passport issues. So we are looking for any solutions that would be possible. We offered to, you know, not even go to his house, just like meet in a, you know, central location, like 20 minutes from his house. But yeah, just hasn't panned out yet. It may still happen. I haven't written him off completely yet. We may still end up getting in contact with him again. I just don't know if it's going to be anytime soon. Yeah, so Charles Crawford has 1 Graviflyer, and then Charles's other Graviflyer right now is sitting with Mike Gamble, another member of our team. And he is retired Boeing engineer, has some APEC presentations that are quite interesting. He is doing a lot of reverse engineering of that one and its circuits for us. Oh, boy noche, yes. It is nighttime now, isn't it? Alexey is originally from Russia. but I think he's half Portuguese or part Portuguese. And so he moved from Russia to Portugal and was living in Portugal for many years. And that was when we got in contact with him, when he mailed the kits to Charles. Charles was like the first one to like get kits from him, right? So when Charles originally got in contact with him, he was already living in Portugal at the time. Even though the videos that I don't know actually if all of Alexey's videos take place in Portugal or if some of them are from Russia. One interesting story about Alexey is supposedly his garage got burgled after he had built his first successful Graviflyer. It got burgled and all of his stuff got stolen. He had to start from scratch, and it took him like another year or two before he was up to speed again on being able to reproduce it. That might have been 2016 though, and I think his videos came out in 2018. So maybe his videos came out after he had already been successful the first few times. I don't know. A solid state version. I would love a solid state version of the Graviflyer. That would make me so happy. I don't know yet whether or not it's possible. I suspect it's possible, but I'm not going to go for that until I have been able to validate the mechanical model first. Right? Start with what you know works, and then move on to the more hypothetical stuff. I've been doing tons of hypotheticals with this thing up until recently, and now I'm trying to go back to more of Alexey's original stuff because I just want to see it lift. Don't we all just want to see this thing get off the ground? So the French guy, that was something that Alexey told us. The French guy that managed to make it lift. Alexey couldn't even remember the guy's name. Couldn't give us any details. Couldn't give us anything about him. Didn't know. And then the Australian team, Alexey didn't know about them, but somebody on the WhatsApp group for the Graviflyer stuff mentioned, oh yeah, we knew about that like, 8 months ago. Where have you been? It's like, this is the first that I'm hearing about it. So that the Australian team is rumor mill. I have nothing to go on for that. And the French guy is straight from Alexey, but wasn't much help in giving us any way to find out who it was. So, c'est la vie. Wait, let me keep increasing voltage here. One other interesting about increasing the voltage is the that you get. That'll start to change as you force more electrons, more charge into these things. Also, you get electrostatic drag from these spinning disks. Also, you get electric and magnetic interactions. So, just non-linearities on top of non-linearities, everything affecting everything else. Is the Graviflyer a capacitor? There are a lot of different smaller capacitors within the greater capacitor that is the Graviflyer. So you have one capacitor between each spinning disc and the center plate. You have one capacitor from bottom to top spinning discs, right? You have the piezo is a capacitor, and you have the interaction of all those together. And then you have the middle disc that, has like a tank circuit, right? That is the Tesla coil. And so then you have that against each of those as well. And let's see how I'm doing. I got so much noise. It's impossible to even see what speed I'm at for the top disk right now, which is unfortunate. See that? How are you supposed to read? See that yellow? I can read the yellow frequency. How the heck am I supposed to read that blue frequency? What you doing here? Okay, there I can kind of see. But yeah, it is quite ugly. And so that's another issue that I have, is that when I put on this high voltage power, my lab view setup that's reading my oscilloscope, it starts going all sorts of wonky. And so I can't really monitor changes in the speeds except audibly with my ear. All right, I'm at 14.3 volts in. I'll probably be able to get this up to max voltage in about maybe another 3 minutes or so. Have you found any overunity effects in your testing? Not quite. I'm not monitoring, like I am monitoring my power demands somewhat, but not enough to know for sure whether or not I was producing, more than I was putting in. I don't think that this is an overunity device. However, I did note about a year ago, I noted that there was interactions between the ultrasound and the Tesla coil, and that the ultrasound seemed like it was affecting some of the Tesla coil harmonics. It seemed like I was getting a power transfer from the ultrasound to the Tesla coil. That was like a year ago. And now recently, like I was saying earlier in this chat, I noted that all these transients from the button pushing are showing up on that Tesla coil. If there is overunity, the one place where you might see it would be the speeds of the discs. So I've had other times where the speeds of the discs just shoots off. It just takes off. When you have the speed of the top and the bottom disc just right at with each other, so they're going the exact same speed, that's when the nonlinearities can really take off. And so the speed of the top and bottom disc will shoot off up or down together. Except when there is some break with the charge between them or something. I don't know. Occasionally we'll get it so just the top rotor or just the bottom rotor will take off. But more times than not, when you get the speeds of the two to match, it will take off together, which, yeah, it's possible. There's some kind of there, but I don't know. Yes, Dr. Charles Bueller is interested in the Graviflyer. We've reached out to him, I think, once to try to do some kind of collaboration, but NASA's head of electrostatics lab guy doesn't have a lot of free time, so we haven't gotten a chance to actually have a meeting with him yet. Maybe Charles might have had a meeting with him already. I don't know. But it takes, a good 3 hours start to finish to get like up to speed on what this thing is and how it's operating and everything like that. Do we have a website? We actually just finished building our website. It doesn't have anything Graviflyer related on it yet, though. So not much use with sharing quite yet. Once we get something useful on the site, then I'll end up sharing it with y'all. But for now, it's kind of a placeholder. As soon as we get lift, that's when the website will be the place where everybody goes to place an order to put something in orbit. Yeah, the Kedium guy over in Africa. So Charles has been talking with him, and it's looking somewhat promising, but the Kedium guy is like kind of hit or miss for when he responds. So we haven't been able to get like a Zoom call with him like we'd like to have, or some kind of have him send us a kit, or something like that. I agree that his device is looking really interesting. Not quite sure what all is going on there, because he's got high current, high voltage, high frequency generation, And then he's got cardboard with holes cut in it in a hexagonal lattice. And somehow that's able to make like a half-kilo rock jump a meter away. Like it's wild. Yeah, don't know what he's got going on there, but it's really cool. Ooh, Get Real says, I read today Alexey doped the center plate with something to help it conduct. If you stay here for a minute, I'll see how I can. Please do find something on it. That is the first I have ever heard of that. Alexey has never mentioned doing anything to the center disc. What I will say is that in the kit that he sent to Charles, it looked like the center disc had rust on it, which everybody was saying, but it's made of aluminum. How does it have rust on it? No, it was just like some like stuck on hard oil grease or something because he got it out of a junkyard. Yeah, he never mentioned doping anything. I know we had one guy in the WhatsApp group who was also, I think, a French guy. He had he did a lot of doping with like the red high voltage goop, and it seemed like that was okay. But I don't want to add any more mass to the spinning stuffs than absolutely necessary. Have I tried the beetle experiment? Beetle wings, Scarab wings, actually. I've done some testing with these. I did some RF sweeps on them to try to see if they had any frequency response at all, right? You start by looking for frequency response, then you move on to the electrostatic response. Because if it has a certain frequency response, you know, like at 20 kilohertz or something, and then you supply your high voltage at 20 kilohertz, you know, you're more likely to get a cool effect. But I didn't get really any decent frequency response off these guys. So I haven't done the high voltage zippy zap on them yet to see if I can get them to electrostatically repel or anything. Also, it's worth mentioning that it was not a beetle wing that Grebennikov used. It was some kind of wasp. When you look at the drawing that he made, I'm not 100% certain that it's a wasp. I'm just strongly suspicious that it was. When you look at the drawing of the bug on his vertical Grebennikov rod thing, it is very, very similar because it's got, you know, these long legs and these long antennae to certain kinds of wasps. However, that could have been like a misdirection because he wanted to misdirect people away from it. And if it wasn't that, then it was some kind of wood beetle specific to Siberia. We've been looking for the specific bug, scouring all sources we can for like the last month and a half. Similar to what Townsend Brown was working on. I suggest going back to earlier in the combo, I talked about how I used these symbols. And I did some TT Brown version testing of this. I don't think that this is operating off of the TT Brown thing because TT Brown stuff didn't really start taking effect until 50 kilovolts, and the max that this thing's operating at is like 20 to 30 kilovolts. Phase lock loop circuit. Yeah, so when Alexey does the pulse off thing and it's creating that EMP, when he holds it down and the frequencies are kind of coming together and increasing up and it's kind of sweeping up, I think, and he has to push it a couple of times, I think what he's doing is he's trying to get the phases to align between something in here, most likely the ultrasound and the Tesla coil. Although it's possible that it's the ultrasound and the high voltage. So the ultrasound, my guess right now, it's all guesses, guys. My guess right now is that the ultrasound frequency, when it's just normal operation, you're trying to get that to interact with the high voltage, pulsed high voltage frequency of around 40 kilohertz. And then when you push down the button, that's when you're operating on the Tesla coil stuff, right? So it's kind of like pushing down the button switches the ultrasound from operating on the high voltage to operating on the Tesla coil, which means, you know, inversion of fields somehow, maybe. And then those phases are locked with the Tesla coil field extending above and below the spinning discs. My guess. It's all guesses. Purple ionic rock gold. I'll try anything, man. Yeah, you can shoot me emails to mightybrain@yahoo.com. Fair warning, I check that email like maybe once every 2 weeks. But yeah, purple ionic gold. That would increase the conductivity and change some of the sound response of the center disc. But I think if anything, doping the center area would be really interesting. The center of the center disc, right? So basically extend outwards from the eddy current, which is just a thin ring that extends around the edges of the spinning discs in the center disc. So yeah, dope that area with something highly conductive to build up additional charge. That could be quite interesting. Yeah, the beetle wings floating above each other on their own. Yeah, no, I've done the drop, you know, throw them at each other. I've done that. That doesn't do jack squat. Unfortunately, there are fake videos out there of people making the beetle wings float. I don't think that that's necessarily like 100% the case, that it's possible that they legitimately can do that. Unfortunately, when you do a YouTube search for it and look for the videos of it, the first things that are going to come up are the fake videos, which is unfortunate. I think Grebennikov had... I think Grebennikov, looking at these things on a slide under a microscope, it's possible that that glass slide might have been a charged surface. I know for sure, because I looked at the other documents for his thing. He had a small battery on board his levity device. And when he would do the startup procedure for it, he would hit a button, and that button would immediately like charge all the surfaces of these wings to like 30 kV. So like the Grebennikov thing is using high voltage, just FYI. But I don't think he had wings in there. I think that's after he'd already switched to the fan out with the holes cut in it. Okay, I need to keep tuning. Turn that up. All right. My high voltage is now sitting at what it should be sitting at. Now I got to let that sit for a few minutes, and then I can turn on the Tesla coil. And then we'll actually get into the actual tuning thing, and you'll see just how disheartening it can be, because what will happen is you'll go through all this tuning, you'll try to find some special sound of some kind, and eventually you'll be like, okay, sure, let's try that. And you do the button. And you only get a couple of tries at the button. And then you can go back and measure your charges and be like, oh, shoot, my center disk is too charged. My bottom disk has lost its charge. I got to turn it off and start all over again from the beginning. Oh, yeah. The harmonics, the 5th and 7th harmonics. So... can you see? Yeah, you can see my old Graviflyer over there that I had the pizza plate. That thing, with its rounded edge and everything, that thing made some beautiful sounds, beautiful vibrational sounds, in part because it's thicker, and so it's not as wobbly as this thing, this center disc, because it's only 1 millimeter thick. It's got so much wobble in it. It's like a really, really loose guitar string, and that thing is like... a nice, bass string that isn't loose, that has a good, good sound response. So I was able to get a lot better resonant sounds off of that than this. Off of this one, I've only been able to achieve the oscillating harmonic sounds like 2 or 3 times. And even then, it was not very pure sounds, and it was not useful sounds. With that one, it was super useful sounds. Like, I knew that I had the proper spacings and speeds of everything with that one. With this one, it's a little touchier. Also, it's worth mentioning the dimensions on this one are larger than Alexey's original. So Alexey always used like 8-inch or 200 millimeter spinning discs and 16-inch or 400 millimeter center disc. I right now am using 250 millimeter or 9.5 inch, 9.25 inch, and like whatever double that is, like 500 millimeter. Exotic propulsion. They leaped off the table. I assume you're talking about the Scarab wings, maybe? Yeah, if you got any videos of that you'd like to share, let me know, man, because I would love to be able to reproduce the beetle wing thing. If for nothing else, then it's just cool. The only thing he seems to keep secret is a metal alloy he discovered or made. It's using that alloy and a disc plate located in the middle of the device. Huh. They make gold plating metal using micro gold. And radio sound and harmonic 11. RX. Cool. I think we are about ready to start actually getting to the cool testing part. I don't know how well it's coming through the microphone, but if I just stay quiet and you listen, you can hear the beat frequency of the 2 discs. I think the top disc is going like 2 to 3 hertz, 60 to 100 RPMs faster than the bottom disc. Which right now, I have the spacings of these discs. I have them set at the amount that they're set at, which right now I think it's 32 millimeters for the top and 35 millimeters for the bottom. I have it set at that because that was where I was trying to balance the speeds of the two because they're both running off the same motor controller. So electrostatic drag and magnetic drag and all that drag, right? The position of one disc affects the speed of the other disc, right? So I try to get them matched like that, as well as the surface charges of the discs. So right now I have it somewhat balanced for that, but it could be balanced better. I'd like it to be such that the top disc goes the same speed as the bottom disc after I'm done adjusting the high voltage. I'm losing my signal here. What's going on? Kill me here. Oh my God. There we go. Hey, I can actually see my speeds. So I'm at 21 hertz for the bottom and 22.8 for the top. So about 1.7, 1.8 hertz difference. All right, now I'm going to turn on my test the coil is the next step. Turn my frequency range up here so we can see a little more. So right now I have the frequency range of this thing set up from 0 to 25 megahertz. Test coil on. Look at that. Now let me zoom out even more so you can see just how far out that goes. So it goes all the way out right now. This is out to about 100 meg. It goes out to like 70, 80 meg out there, but that's at minus 80 dBm down here, which, for those who aren't familiar with RF, minus like 60 or 70 is usually considered your noise floor. So even though I have, you can't really see it too well. Even though I have a lot of like little sine waves down at this high end, which right now that's like 50 megahertz up here. That's down so low and quiet at the minus 80 dBm that it's not worth mentioning. But you see I get these transients up here. Transients are nice. You can see I got a big old dip. Big old dip at about the 16 to, what is that? That's like 15.8 to 16.5. Right, so call it about 16 meg. I got an interesting dip, which means power is going somewhere. Got another dip down there that's probably at like 8 or 4. What's that? 4. So it's kind of like you have harmonics and you have anti-harmonics. Anyways, enough with that. So Alexey says, turn on the Tesla coil, do a couple up and down ramps of the power, which you can see when I get all the way to the end, how much the power changes. There's the end, go back, end, go back. So if I zoom in a little bit more, down to that low end. So the area that I'm really interested in is 7 to 12 megahertz, because that's where the ultrasound transients seem to be playing a big role. So trace. So somewhere here to here. In this range, when I do my ultrasound pulsing, we should see something interesting. What I'm going to do, though, is I'm going to max hold that. There we go. All right, so now the yellow is my max hold line and the purple is my live line. So as I adjust, and you probably can't see that on screen very easily. I don't know if I can turn off lights to make that easier to see, or maybe I can rig brightness. Well, that makes it a little easier to see the declinations. At least there's that. Okay. Ooh, Turin, that's a good idea. Turin's saying, have you thought about using ceramic linkages to spin the discs at a fixed gear ratio? So I don't want to do anything to impede or help the speed of the discs. I think that the changes in the speeds of the discs from all of these inputs might be a really important component to the tuning. And until I'm able to reliably get lift, I'm not going to know for certain. But strong suspicion that when you're turning up or down the Tesla coil, or you're turning up the high voltage, or you're pulsing ultrasound, or doing anything that does affect charges on the disc and therefore speeds of the discs, that they need to be able to self-correct. They need to be able to maintain their like synchronization with each other based upon like resonances rather than like forcing them into it. You might be better off forcing them into it. I don't know, but I suspect not. All right, so I am now ready to start doing the ultrasound stuff. Let me get my ultrasound all the way turned to the proper amount. 10 turns. Oh man, I've been going for 2 hours. Yeah, normally when I'm doing this testing, I'm not talking so much. I'll do 1 to 2 hours for one good test run. And then I'll tweak something, and I'll do it again. And I'll tweak something, I'll do it again. And I try to get at least 2, sometimes 3 test runs in a day before I'm just like totally done. And, you know, you stare at this thing for that many hours at a time. You just get so disheartened every single time you push the button and it doesn't lift. And every time your fingers crossed for hoping, come on, this is going to be it. It's never it. Anyways, all right. I am now turning on the ultrasound. Turn on here so we can see it. Zoom in so we can see it even better. All right, so it's not a super steady pot, so potentiometer. So just tapping it will cause it to change. So that's the other thing is you got to wait about 10 seconds. You're supposed to wait. Based off my observations, you're supposed to wait about 10 seconds between ultrasound adjustments, which, did I mention, this is a 10-turn pot, and each adjustment is like a 32nd of a turn. It's a lot. But the amplitude goes down so much in the 30 to 40 kilohertz range, 20 to 40 kilohertz range, that like I feel okay making larger adjustments there. But in the low range, I make very small adjustments. And what I'm doing is I'm listening. This is all I can really do. I'm listening for either a special sound that's not the buzzer, or I am listening for a change in the vibration and the beat frequency. Right? I'm listening for a speed up or a slow down in that, or I'm looking for which corresponds to. What just happened? What just happened? There we go. Ooh, isn't that lovely? Will you do more live streams? Probably. This is more just me doing my regular daily testing, and I figured why not share that with you all. Also, it's a lot easier than recording a 14 gigabyte 2-hour 2K video and then uploading that. So yeah, I might do more live streams of the testing, but like you'll quickly realize just how boring this process can be. Tedious is probably a better word. So Alexey does a lot of his tuning, most all of his tuning by ear. So trying to be true to form, I try to use my ears as much as anything else. Is that sound hurting you? No, not terribly, but I'm sure the microphone is picking up really, really bad. Don't worry, I'm almost out of the audible range. Now it's only the kids that are going to be hurting. Those who can still hear below 16 kilohertz. So there's harmonics. That's why it keeps going from like a really high pitched sound back to a lower pitched sound. There's harmonics in there. This circuit is not putting out a single sine wave. It's putting out a bunch of harmonics. I don't think I can really show you in this stream. If I do future live streams, I'll try to set it up so I'm screen sharing. And then you can see on the audio analysis software how you have these multiple harmonics being produced from this guy. And now we're starting to get out of the audible range. Wait, 10 microseconds. I'm trying to estimate what the frequency is right now. I'm seeing I got 20 microseconds per division on here. There we go. 20 microseconds per division. I got 1, 2, 3 ish. So about 60 microseconds. What is that in 1 divided by 60e minus 6? So yeah, it's about 17 kilohertz right now. Now you can hear it starting to oscillate down into the lower harmonic again. We are now at the most tedious part. This is the part that I spend 90% of my time in the tuning process on, is ultrasound adjustments. Now, okay, one thing that I'm doing wrong. When Alexey does this step, he is sweeping the Tesla coil up and down as he makes these minor adjustments. So he's doing sweeps, slow sweeps with the Tesla coil. And I'll turn it up a little bit on the ultrasound, and then keep sweeping. And one thing I'll say about the Tesla coil, it significantly increases the electrostatic interactions occurring there at those spinning discs. Yesterday, when I had like 10 or 12 millimeter spacing for the top disc, which is really close, right? Like a centimeter. It was at 13 volts in. I wasn't even my 16 volts in yet for the high voltage. At 13 volts in, I started getting arcing across that 10 millimeter gap, which you figure about a kilovolt per millimeter. That means I had a difference of potential of at least 10 kilovolts, 10 to 15 kilovolts. And that was really weird because I measured the static charge of my top disc, and it was only measuring at like +5 or +6 kV. But +5 or +6, and then the Tesla coil is giving me like, 2 kilovolts peak to peak, ±1. Still far cry from 10. Yeah, if you're all interested in watching live streams of this, I am more than happy to do it. I figure this time of day is probably the best time if people wanted to watch it. What do y'all think? Is there another time than this that would work better if y'all wanted to watch it? I tend to do most of my testing in the afternoon and evening, and sometimes into the very early morning. But I've considered just having the camera going, nonstop, and doing my test recordings that way, because I'm running out of hard drive space. You figure I'm recording something like 60 gigabytes a week, and then of that, I'm trying to, figure out, is any of those worth posting? And so I post very few of them, because usually I wait until I have something that I think is really cool, worth sharing. Let's see. Would the different size you have require a different frequency range? Most certainly. So the diameter of the discs seems like it might be a really important feature of all of this. Maybe, potentially. So since I have a longer diameter, that's a longer wavelength, that's a slightly lower frequency. But then again, Alexey had variation in his diameters. I think in one setup, he had like 8 inches, 8 1/4 inches. In another one, he had like 8 3/4 inches. So like there's variation in the diameters that he used. And his center disc, I think one of them was like 15.3 inches and another one was like 16.4 inches or something like that. So like that's part of the frustration, is that this thing is so easy. Alexi makes it look so easy, and it seems like it's just a junkyard built device that should be very forgiving for tuning. But it is not. It is a very unforgiving thing for tuning. I might end up trying to do these videos a little earlier in the day if I am going to do them. I'm still undecided whether I'm going to do more live videos, but if y'all like them, I'll probably do it. Yeah, I'm over on Pacific Coast time, so figure, 4 or 5 p.m. around here means that most likely East Coast time, 7, 8 p.m., people are going to be home where you're most likely to actually sit down and watch something. And keep doing more tuning. See now, my ultrasound pink signal here has almost completely flattened out. So like, it wouldn't matter if I just did a pause shot. How the heck am I supposed to be able to read a frequency on that, right? There's nothing to read. I mean, kinda, maybe, but this circuit does not seem to matter much for normal operation. Pulse operation, completely different story. But for normal operation, it seems like this circuit does not matter all that much when you go above 20 to 25 kilohertz. Which is weird, because Alexi said 90 kilohertz, right? Okay. I'm starting to see some transients on there as I adjust the Tesla coil. See, it's updating very slowly because I got it really zoomed in on there, so I can still hopefully kind of monitor my RPMs. Another way that I can monitor my Tesla coil is based off my power. So I know, based off of prior testing the circuit by itself, that with my power inputs, I know where my bottom out zone for power output is. Means that I'm at the crossover point where I've gone up in frequency, I've reached the top, and now I'm starting to come back down. So I'm still a little ways away from that. I'm going to start going a little faster here. So what I think I'm looking for is you set the ultrasound frequency, and then when you do a sweep, if the frequencies are overlapping, this sweep should cause a change in the beat frequency or a change in the vibration. Like, you'll hear it. I know that I've had that happen a ton of times where the Tesla coil strongly affects the beat frequency. All right, I am ballpark. I'd say I have probably 2 more full turns of this ultrasound knob. Every once in a while, I'll hear like it miss a beat frequency. I have like 2 more full turns of this ultrasound knob, and then I'll scream through it really fast until I get to the other end. And then I'll probably end up doing a pulse at the other end around the audible range. One thing you can do, or I can do, is I can hold down this pulse button and I can set the frequency of that pulse. Extra spikes you get, faster frequency you get when you're holding the button down. I can pre-game it and I can set it to that so that that frequency is the same as my lowest harmonic for the Tesla coil or for my high voltage DC. I can like match those two up beforehand, and then I just don't touch the frequency and I just do a pulse. But I've tried that and I haven't really noticed with either of those. I haven't noticed much change. One other thing is I'm watching to see if any of my harmonics end up like going higher, right? If all of a sudden there's a frequency of the ultrasound where the Tesla coil sweep adds additional amplitude to, or loses amplitude from one of the harmonics. Another thing you can do is you can watch the power going into the ultrasound, and you can see if it changes when you adjust the Tesla coil, which there's a couple of spots where it'll switch by like 5 milliwatts, but that ain't really anything to write home about. What's your education? I joined the Air Force right out of high school. I learned how to be an avionics technician, so I was repairing 117 different kinds of electronic systems on the fighter jets, as well as a dozen different test stations that those are on. I did that for 11 years. Got my associate's degree in science in electronics while I was in. I quit the military to go to school full-time for physics. I did that for about 2 years until it broke me. Diffie-Q, man. Differential equations. I spent 3 days straight without sleep trying to learn just one chapter in that book. And I retook that class 3 times in a row. And every time at that same stupid chapter of integrating factors, it kicked my butt. And that was the moment I knew, okay, I've tried 3 different times in this class to get integrating factors. And that's like basic level Diffie-Q stuff that you need for physics. I was like, if I am having this much trouble on the math side, I'm going to have a lot of trouble trying to do this as a career. So then I left that, and I went to work for an aerospace company that does optics for airplanes, all the heads-up displays for pilots, simulators used for flight simulator, projectors used for flight simulators. So there I was building those projectors. I was building the test stations for those projectors. And I moved on. I started going just fixing test stations there. And I went to school for more electrical engineering while I was there. But school doesn't treat me well, guys. I am bad at school. I much prefer to read white papers and read textbooks on my own just for the joy of learning, rather than have to stress out about a midterm that has 3 questions on it that's going to determine whether or not you fail this class because you couldn't remember, one important thing for 1 question. Yeah, that kind of bull crap. And then on top of it, they have the goal to charge you so much money for it that it's like, essentially, this 1 question is worth $1,000. If you can't answer one question on one test, that's $1,000 question. Like, seriously, guys? Seriously? Anyways, that's enough ranting about my love for higher education. Alexey Chekurkov adjusted the pulse width on the capacitor, made the field pulsate at frequencies at which gravitational waves deflected. Okay. So gravitational waves. The jury is still out on whether or not there is electromagnetic and gravitational interactions going on, right? Whether or not that's a thing. I think that there's a high probability that it is a thing, but not 100% certain on that one yet. With this junkyard built device being able to manipulate gravity waves, I have a really hard time swallowing that pill. I have a lot easier time swallowing it's got a lot of high charges and spinning magnets, and so it's doing frequencies of electromagnetic fields, right? Like that's super easy to swallow. Somehow converting that into saying that it is doing that it is somehow interacting with some other gravitational frequency that you can't even measure with equipment. If you can't measure that gravitational frequency with equipment, how the heck are you supposed to be able to, tune into it with this thing? I'm an engineer, technician engineer. I got to be able to see a wave and tweak a knob to make my wave match that wave. So if that wave's the gravity wave, I got to be able to tweak my thing to be able to go. If I can't measure that gravity wave, I don't know how the heck I'm supposed to be able to tune it to the gravity wave. All right, I am just about bottomed out on the Tesla coil. I should say topped out for the top frequency that it's going to make. So every once in a while, I get a sound that I swear is the fishing reel unwinding sound that Alexi says. But it also kind of sounds like a squeaky bearing. All right, I've now reached the top of the ultrasound frequency. How about I do the pulse here? I've always been doing the pulse at the high amplitude ends for the low frequency. I'm going to do a pulse at the top end. Before I do, we got static meter. We're sitting at -3 kV on bottom, which is not great. That means I might have taken too long to do this. Sitting at about the same, +3 kV on the top. And our center is barely negatively charged at -0.5. All right, so -3.2, +3.2, -0.5. When I do this pulse, I think those numbers are going to change. All right, pulsing now. Pulse, 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 pulse. So Alexi has a method where he pulses it, pushes it, waits 4 seconds, pushes it, waits 3 seconds, pushes it, waits 2 seconds, pushes it, and then holds it for like a half a second, and then it takes off, right? That's how he does it. My transients, EMPs that I see on here suggest that you should pulse it much faster. All right. Now that I've pulsed the pulse, let's see what we're sitting at. Okay, bottom is still at -3.2. We're sitting at about -0.7. And now we're at +2. +2, +3? +3. Okay. It didn't change that much. How about I go all the way to the other end where I know that that amplitude is going to be high. I do some pulses there, see if it changes, and then I will probably wrap this up because I've been going for almost 2.5 hours. All right, you can hear that annoying sound. Oh yeah, Behold the song of my people. Most annoying sound I can possibly find. Okay. Now, you can hear how it'll change between those two modes. That might be a thing as well. That might be part of what Alexey is doing, is he's getting the ultrasound buzzer to enter a different resonance mode. If I do this again and you can see my screen for the audio spectrum thing, it becomes a lot easier to see how what it's doing is it's got like two harmonics, right? A 10 kilohertz and a 20 kilohertz. And then you'll tap it and it'll jump up halfway in between both of those. So then it'll go 15 and 25 kilohertz, right? It's like oscillating between those two. It's also worth mentioning that if I unplug my ultrasound up there and I turn this down, this ultrasound circuit all the way to the end, I'll still get sound coming directly out of the circuit itself. Like the wires in here are ringing. All right, so let's see if that has changed my charges. All right, now we're sitting at -2 on the bottom. Ha ha! I'm not a liar. It's -2 on the bottom. It was -3. Center is still sitting at -0.5. Top disk is still sitting at +3. Okay, that is not nearly as much of a change as I normally see. I think in part because I have this positions of these rotors balanced so well. I think I'm getting less of a change. I'm getting less of a change when I do this pulsing than I was getting in the past. In the past, like I said, I would go from like -6 kV or -10 kV on the bottom, and I would go all the way down to like -1 or -2 kV. Like I would lose all of it. Now right off the bat, like that's a big observable thing. And then the top disk would like usually go up. It would go from like +1 kV. So the top disk rarely would gain any positive charge at all from the high voltage stuff. But when I would do the pulse at farther distances, the top disk would go from +1 up to like +3 or +4 kV. And now they're not really doing that as much now that I have them in a more balanced position. So this is further reinforcing that the spacing distances matters a ton. Anyways, let me shut her down. All right, test coil off. High voltage off. All right, everything except the rotors is off. I like to usually let it wind down a little bit. Keep the rotors spinning, turn everything else off, and just listen for a change as that further reinforcement of belief that, you know, all of these added things are doing something because I can observe how the speeds change once I remove those external stimuli. Don't sweat the math, man. That's what AI is for. You know, you got to be able to understand it well enough that you can read white papers and be able to recognize like what they're talking about, because the math is a language all in and of itself. One. Two, I think some of the coolest stuff I've ever read has been math white papers. Like, there is so much out there in the world of math that never makes it out into the rest of the world because people like don't think in that language. But oh my God, like the overlap between some mathematical things and the physical world that other people don't like recognize because it's too esoteric math. Like, that's the stuff that gives me goosebumps and keeps me up at night. Is there's a math thing that's like a Lego block of the universe, and it shows up all over the place. It shows up in DNA, it shows up in music, it shows up in particle physics, it shows up all over the place. And like, there's only a couple of physics models that even like invoke this thing, but like it was originally just found as like, hey, here's this math thing, isn't it pretty? And then people found out in physics, oh, that applies to a bunch of stuff over here. Like, what? So you got to be able to understand enough of it to at least be able to appreciate the beauty of this universe. Motors are too strong. They are pushing through the frequency being lined up. The Tesla coil can't slow or speed them up. Oh, sort of, kind of. When you spin the discs slower, not too slow, but slower, like around 18 to 20 hertz, that's when you're more likely to get a better response from the Tesla coil than when you're spinning at like 35 to 45 hertz. When you're spinning them that fast, you don't tend to get as much. But I have found that from using my RF, I got a ham radio transceiver here that I was using for a while instead of a Tesla coil. And so I was trying to see what frequencies cause the greatest responses on here. And I noted that around the 14 megahertz range, I was able to get changes of like, I think 150 RPMs or something like that. Like, I was getting massive changes in RPMs just from applying an RF signal to this center disc. Really line from lower distance when talking. Search for downsloping noise. Okay, not exactly, but somewhat related. So the transient pulse from the EMP, from the ultrasound, when you pulse it off, it is an exponentially decaying sine wave. So it goes, really steep up, then sweeps down below the zero, then comes up in, lower amplitude and oscillates and dies out, right? That's kind of what it's doing. I don't know how much that's related to the fishing reel noise, because that's after you hear the fishing reel noise is you apply that pulse. But some of the times when I thought I've heard that special sound is when one of the or both of the discs start speeding up or slowing down really fast together because their speeds match. Other times are when you get special beat frequencies where everything starts to sing like musical notes. And then, like I said earlier, the bearings kind of squeaking a little bit can kind of sound like it. What's some others? Like, I've had like a dozen different times where I'm like, oh, that's the sound, and it's never the sound. Alexey says that he hears the sound coming from his Tesla coil. Maybe. I mean, I've never heard any sound come from a Tesla coil except from the little wire on the end, but he says it's not coming from that. Yeah, I don't know. Oh, fractals and Fibonacci sequence? Oh, man, no. You're going to get me onto the math thing. So, octonians. Okay, so you got square root of -1. That's I. That's the imaginary number, right? Then in the 1800s, there's this dude who figured out that you can do that where the square root of -1 is not equal to the square root of -1. So square root of -1 is equivalent to like a rotation, right? And you can have a rotation in more than one way. You can have a rotation that way, or you can have a rotation that way. So those are called quaternions, I, J, and K. Those are used all the time for flight computers because it has to know how it's positioned in the sky. And they all talk about rotations, right? Well, you can extend that again, but every time you do this extension, you lose a special feature. So you can do that extension again, and you get, instead of 4 dimensions for the quaternions, 1, I, J, and K, now you have 8 dimensions. And that 8-dimensional thing is called an octonion. And octonions are like, that's high-level grad math, man. Like, octonions, I'm not going to even pretend to really understand them, but what I have been able to grok about them is that they are, they show up in a lot of physics models. It just so happens that DNA can be, the language of DNA can be described in quaternions, but that doesn't fully describe them. If you extend it to octonions, it does fully describe. Octonions are also very useful for stochastic probability type stuff. So all quantum mechanics, right? That's why, part of the reason why it shows up in physics. And then music. So music theory itself, usually we're taught about Western music as music, right? That's music theory, is normally Western music. But Western music isn't the whole of music theory. You have to go over to India to see the whole of music theory. And over in India, instead of, you know, whole note or whole step, half step, you know, A sharp, B, C, C sharp, right? Instead of those half steps, they have quarter steps. They have notes in between those notes. When you do that, you start getting into true music theory, like fundamental music theory, which is fundamentally mathematical. And it actually maps, music theory maps onto a donut, onto a torus. It's called the tonnets, Tonnetz, the tonnets. That torus is described, once again, it's described very well with quaternions. But if you extend it to the octonions, you get all the possible music theories that you can have. So you got DNA, you got music, you got particle physics. It's this mathematical Lego block that the creator decided, I'm going to reuse this bit of code over and over and over in all these different spots. And that's just like 3 examples. I'm sure it shows up in a bunch of other places, but those are the first 3 that come to mind. As far as fractals, oh, if you want to get me on fractals, let me turn this thing off. So fractals are, my personal thought, fractals are libraries. So in the same way that code, computer code, you have to have your whole library of all the possible commands you can have to be able to write your code, right? So fractals seem like libraries for code, and this code is written in geometrical math forms, right? So different fractals are different libraries, except there are certain fractals that contain other fractals, so sub-libraries within libraries. So the Mandelbrot is kind of like this mother library of libraries. And then each of the Julia sets, each of the slices out of that are kind of like subdomains, sub libraries outside of that. I'm going to geek out hard here on something. So the string theory stuff has a deal where it talks about this thing called monster moonshine. So you have to understand this stuff called group theory, which is basically all the different possible permutations on how something can be rotated or moved somehow. That's group theory. Well, as you extend that into higher and higher dimensions, you see all these cool symmetries pop out. And one of the craziest things that ever happened in the history of group theory was this guy, Conway, figured out this thing called the monster group. And this monster group is absolutely freaking massive. It's like 4 billion by 4 billion or something like that. I don't know. It's stinking crazy huge matricey with like all possible beauty within it, right? Well, string theorists noticed that there was this one particular number that cropped up in string theory that just so happened to correspond to the monster group. And so that's where this monstrous moonshine theory or moonshine M theory for string theory comes out. Well, that thing is called the J function. That number, it's 196,820 or some odd number like that. That number shows up in string theory, and it shows up in the monster group as the number of cells for a single element of the monster group, a single like row or column or whatever. That number is called the J function. It shows up in the Julia sets of the Mandelbrot. So tracking this back, it looks like string theory has a thing, right? Physics string theory has a thing which comes from math monster group, which also relates over to the fractals of the Mandelbrot. Yeah. The whole universe is all code, man. Anyways, I have gone far off the topic of the Graviflyer. I haven't seen too many mathematicians trying to build flying saucer in the garage. You have a special sauce, you're eating in the math. Oh, what's going on, Isaiah? Cool. What's up, bro? What use case would we get out of these theories? So, if you understand the code that the universe is written in, you can start writing your own code, right? So I am a huge proponent of the simulation model. I really like looking at the information theory relationships between perfect information, or when you want to get a single bit transmitted from point A to point B, you can't just transmit a single bit because there might be noise or something that flips that bit. That would be an error, right? So you have to correct for these errors. So if you want to correct for a single bit error, you have to send 3 bits. And then if one of those bits gets flipped, majority rules, you know that the other 2 bits are most likely. So if you want to send a 1, you send all 1s. If the receiver gets 0, 1, 1, they know a bit got flipped and the original message was 1, right? So that's the basics of information theory and error correcting. Is you want to be able to transmit a code from point A to point B. So it turns out this all maps back onto group theory, and that if you want to have the most efficient code possible, right, the highest number of bits that you can send for the fewest number of bits that it's going to cost for error correction, it turns out 8 and 12 and 24 are the magic numbers for that. 8 is called the Hammond code or Hamming code. And then the 12 dimension one is called the Golay code. So those information theory codes, they go all over the place throughout the mathematical world. And they happen to touch upon enough places in the math world that also relate to physics things to lend me to believe that there is some computational baseline of reality. If you can understand what that computational baseline is, it's possible you might be able to do things with that. For example, if you know that error correction is what is going on to create a gravitational pull, right? The number of processes that have to be performed, the number of computations that have to be performed in a given space is equivalent to the amount of gravitational pull that space is doing. Now you just need to create a super chaotic system in a very small space in order to be able to generate gravity. That would be one example. I don't know much more than that. Anyways, I think I'm going to wind down and end the stream. Super awesome. Thanks for everybody who stuck along, and listened to my rantings about math and stuff, and watched all of this interesting Graviflyer stuff. Anyways, peace out, dudes and dudettes.